All right, welcome to section 3.4, exponential and logarithmic equations. So we're basically going to, we know how to do the properties of exponents and logs. Now we're going to learn how to solve equations that involve exponents and logs. Okay, so we're going to apply the properties of logs and exponents to solve equations. And on the next two pages, all I've basically done is given you what the properties are for the exponents and logs. Remember, multiplication means add, division means subtract, and then the exponents can go to the front for the power property. All right, so example one. These are just a bunch of examples. They all look certain ways, so you'll know what to do with them. So if you have numbers raised to exponents on both sides, you should be able to turn those numbers into the same base. And if we can turn them into the same base, then we can solve the problem. So if we know to 36 and 6, I can turn 36 into a base of 6 by doing 6 squared. And then I'm going to bring down my x plus 1, and then I have 6 to the x plus 6. Now, the exponent property says if I have something, a power raised to a power, we multiply. So I have 6, so 2 times x is 2x, 2 times 1 is plus 2, and this is equal to 6 to the x plus 6. Okay, so now we have the same base. It says they're equal to each other, and if we want to know what x is, if we have the same base, we can take the exponents and we can set them equal to each other. So we should be able to do 2x plus 2 equals x plus 6, and we should be able to solve this equation. So I'm going to subtract 2 first. So 2x equals x plus 4, 6 minus 2, and now I need the x's on the left, so I'm going to subtract x. So 2x minus 1x is x equals positive 4. So the solution to this problem is 4. Okay. All right, same thing with b. b is a little bit tougher though. So we need to somehow get 64 and 1/2 to the same base. Okay. So let's recap here. So would you agree that 1/2 is 2 to the negative first power? Okay, I hope you do. And I still have the c there. And now I'm going to turn, so this is in a base of 2. I'm going to turn 64 into a base of 2, which is 2 to the 6th power. And I still have a 1/2 there. Okay, so now we have to multiply our exponents. So 2 to the negative 1 times c is negative c. And now I have, so this is a 6. 6 times 1/2, what's half of 6? So that's 3. All right, so now I have same base with exponents. We can just set our exponents equal to each other and we can solve. So negative c equals 3. Divide by negative 1, divide by negative 1. So c should equal negative 3. Okay? So if you have numbers with exponents on both sides, you have to somehow come up with the same base. That's why I wrote same base. All right, example 2. Solve equation. Exponent on each, we're going to, this and this parentheses are going to tell us what we need to do. We're going to exponent each side. Okay? So we have our x is built into our log here. So somehow we got to get this x out of here. Okay? All right, so what we're going to do is we're going to exponent each side. Now, how are we going to get rid of an ln? Well, if I do e raised to the, and if I do it to the left, I got to do it to the right, we should be able to get rid of that ln. Because remember, the ln is log base e. So I have e raised to that log base e. That will cancel, and I'm left with x equals e to the 6th power. Now, we have a calculator to be able to figure that out. So e to the 6th power is second ln to the 6th power, and that is equal to 403.43. 403.43. 403.43. There's my x. So we used raising the equation to something to get rid of our logs so we can attack the problem. Okay? So now let's do the second one. I need to get the log by itself, so I'm going to subtract 6. So I have 2 log of 5x equals 18 minus 6 is 12. Okay, we're going to divide by 2, divide by 2. So I have log of 5x equals 12 divided by 2, which is 6. Okay, so now my log is by itself. I need to get rid of a log base 10, so I'm going to do 10 raised to the on both sides. That will get rid of my 10 and my log base 10. I'll left with my 5x equals 10 to the 6th power. So that's 10 to the 6th power, and then we're going to divide by 5. So x equals, let's do this in our calculator, 10 raised to the 6th power is 1,000,000 divided by 5 gives me an answer of 200,000. So 200,000 is my correct answer. Okay, so please remind me, we're going to do C in class. Remind me to do that one. All right, so example 3. Very similar to the same thing, but now we might need to, so it says exponent each side, but we're going to probably have to use our properties to help with these. Okay, so I have my log on the left. Okay, I can't really do much with that. Notice they're all log base 4, so I should be able to do something with these. On the right, I have a plus sign. And remember, plus means multiply. So I'm going to take 3 and I'm going to multiply it by x plus 2. Okay, so we combine the two logs on the right with the multiplication property. Okay, now what can I do? I can do, they're both log base 4s. I'm going to do 4 raised to the log base 4 on both sides. So that will cancel out on the left. I'm left with x equals. This will cancel out on the right. I'm left with distribute 3x, and 3 times 2 is 6. Okay, so let's solve this. I'm going to subtract 3x, and I get, this is negative 2x equals 6. And then divide by negative 2, divide by negative 2, I get x equals negative 3. Okay, so once again, we combined our logs using our properties, and then we did the same thing we just did on example 2 by exponenting each side. Okay, please remind me, we'll do this problem together, but you're probably going to want to do 3 raised to the, and I think you'll be able to get that pretty easily. Okay, remind me, we'll do that one in class tomorrow. And then last but not least, I believe, last but not least, we're going to do example 4. It says solve each expression, and this one we're going to log both sides. So how do I know I'm going to log both sides? When you have a number raised to x, and all you have is a single number on the other side. So e raised to x with a single number on the side, you're going to log both sides. Okay, so what does this look like? So I need to get rid of this 4. So I can do log base 4 on both sides to get rid of it. And if whatever I do to the left, I got to do to the right. So notice, oops, I made a typo here. Let me get rid of this. This should not be 4. This should be an x. Okay, because it's an x here. So log base 4 goes away. I'm left with x equals, and then log base 4 of 13. Well, I can use my change of base formula to do that. It's log of 13 divided by log of 4, and that will give me my answer of, so log of 13 divided by log of 4, and hit enter, and x is equal to, what was that, 1.85. 1.85. Okay, so you do this same thing. Okay, so what do I need to do to get rid of the e? All right, so instead of logging both sides, I'm going to natural log both sides. So I'm going to do ln of e, 4 minus 3x, equals ln of 6. ln of e cancels. I'm left with 4 minus 3x equals ln of 6. So I'm going to subtract 4. Remember, I'm trying to get the x by itself, so I'm going to subtract 4. So negative 3x equals ln of 6 minus 4. And then I'm going to divide by negative 3 to get the x by itself. So ln of 6 minus 4 divided by negative 3, that's a calculator problem. So I'm going to do the top first. Ln of 6 minus 4, enter. And I'm going to divide that by negative 3, and it will give me an answer of 0.74. X equals 0.74. And there we have it. So that's how we solve equations using logs and exponents. Remind me to do those extra problems in class. Have a good night, and I will see you tomorrow.